trapezoids. First thing we're going to do is we're going to talk about the parts of a trapezoid. Trapezoids will always have four sides because it is a quadrilateral. This little extra piece in the middle here, we're going to talk about what that is when we get done. But what a trapezoid will have is basically exactly one pair of parallel sides. Those parallel ones are called bases. Now keep in mind, the bases don't have to be on top and bottom. They can be on the right and the left, but if they're the parallel parts, they're still what you're looking for as the bases. So the parallel ones are called bases. Well, then they have to be a quadrilateral, there have to be two that kind of connect those, correct? In this particular figure, they appear to be the same, but they don't have to be. For example, you could have a trapezoid that looks more like this, correct? They're still called the same thing. Does anybody believe they know what these green segments over here on that trapezoid are called? Yes. Legs is correct. So then these are also called legs over on this one, and I will outline them in red. Legs, legs. So basically the parallel ones are the bases, the non-parallel are the legs. Okay? Any questions on that? All right. The median. Well, we've talked about the median before, but it was the median of a what? Where did we talk about a median before? What type of object? Yes. Triangle. Triangle had a median. It was right in the middle. Oh, no surprise then that. The median of a trapezoid, very specific here, is the segment that joins the midpoints of the legs. Now, in your picture, this is very important to draw it this particular way. If it's hitting the midpoint, it means that those two are congruent, correct? And it means those two are congruent. How come I have not put the same marking on all four pieces? Because there's no guarantee they're all the same, and this is the best example of that. If I put the median in here, that's the same as that. That's the same as that. You see how they are not all four the same? It's possible that all four are the same, but no guarantee. Anybody know something about the median that you like to share? There's something very important about the median here. I'm not talking about the length of the median. That is actually something that you can find. How would the median relate to the two bases? Yeah. Yeah, it's kind of the median of both of them. For example, if I told you this was, 8 and this was 10, well, obviously that one in the middle has got to be bigger than 8, right? And it's got to be less than 10. And in fact, when you do medians, whenever you did it with just regular numbers, you cross them off all the way in, right? It was a distance kind of thing. And so what do you suppose? How long is this median? It's 9, all right? Right? And the formula you can use for that wasn't really what I was looking for, but the formula you can use for that, there it is. And I'll give you another version of that. In fact, I'll move it up so you can see it. They say take base 1 plus base 2, that's all that is, subscript there, and take it times a half. Some people prefer to see the formula as base 1 plus base 2 just divided by 2. That works. It depends on how you like to do the math. Both should get you the correct answer. And if you look at the case I had, base 1 we'll say is 8, base 2 is 10. Well, if you add those together, that's 18. Divide by 2, 9. Okay. What I was really not what I was looking for there, but what I was really looking for, which will prove very important, is I'm allowed to do this. So now what can you tell about the median? It better be parallel to the basis. Okay? And that's going to prove very, very important. And same thing for this one over here. If this was the picture that you wanted to use, like that's parallel as well. Okay? So far I've been talking about just any old type of trapezoid, no specific types. There is a specific type we will talk about in a little bit. But so far we're just going to talk about any old trapezoid. It just has one pair of parallel sides and one that's not. Any questions so far? Well, here it says we have a trapezoid, CDFA, and BE is the median. Seeing I told you BE is the median, do I have to tell you which ones are the bases then? If I told you BE is the median? Well, you should be able to tell, right? Because it should be parallel to those, right? And so all of these here should be parallel, and we were told that's the median, so we can do this, right? And that's before I even look at a question. That's what the directions basically have told me. Okay. So if DF, is 32, are we able to calculate EF? Quite simply, right? It's just half of that, right? Because it would be 16 and 16. No big surprise there. Based on that being 32, am I allowed to calculate BA? No, we can't, can we? We don't know. Okay, because we don't know all four of those segments are the same. We just know those two over there. So that's all we could do there. All right, let's try another one. AF, where is that? Here it is. 22. CD is 18. Determine BE. Well, BE is the median, so we would use the median formula. Does it matter which one's base 1 and which one's base 2? Does that really matter in the formula? No, so you just pick. So we'll say base 1 is 18, plus base 2 is 22. What do you get if you add those two together? 40. Is 40 the length of the median? No, because what do I have to do yet? I have to divide by 2, because that's what the formula tells you to do. So you could divide this by 2, which tells you 20. Now notice, from 18 to 20, the distance is 2, right? And from 20 to 22, the distance is 2. Okay? And so that should work every time with that median, because that's really what you're doing when you did all that work by crossing off all those numbers when you did mean, median, and mode and all that stuff. So the answer is 20. This next one will be interesting to see if you can figure this one out. If you can, I'm not too worried. Oops. It states on number 3 that F is 82, right? It wants Deb. Anybody believe they know the angle DEB? What that measure needs to be? Yes. It does have to be 82. Very good. And let me explain why. Because here are your parallel lines cut by a transversal. What kind of angles are where the 82s are? What's the name of those? Yeah. Corresponding. And corresponding are congruent. So in fact, could I have asked you for the one where I just put the red dot? I could have asked you for that, couldn't I? Okay. That has to be, well, yeah, 98, because it has to be 180 total, right? Supplementary. So then you could also tell me that one, right? Yeah. Now you can't really flip over to the other side because this isn't what's the next type of trapezoid we're going to look for, but we can do all of them on that side. Okay. So the answer is 82. We'll do one more, and then we'll talk about isosceles, and then I think I'll let you go on a few problems, so you don't have to listen to me talk anymore. CD. Whoops. You had to know algebra was going to find its way in here somehow. We have a base, and the median. But it's algebra. Think the formula still holds, though? Add base 1 and base 2 and divide by 2, and you better get the median? Man, it still holds, and it's not just because it's a different picture, it doesn't work. And so let's go ahead and do that. We've got one base plus the other base better equal the median if I divide by 2, correct? Oh, that looks horrible. Well, we better work on that. Remember, the division bar is a grouping symbol. It says kind of take care of the numerator first and then take care of the denominator if you can. And so the 2x and the 4x, I can add that together and get 6x. How about the minus 3 and the positive 7? End result is a positive 4, which I am to divide by 2, and it should equal 11. You actually have two very, very good choices here to solve the rest. It's actually a fairly good choice to actually go ahead and divide both of those by 2 at this point. That's what it's saying, divide them both by 2, and you could do that. The other option that most of you are probably going to use is the one way to get rid of dividing by 2 is to multiply both sides by 2. When I do that, these cancel. 6x plus 4 equals 22. Subtract 4. 6x is 18. Divide by 6. X is 3. Here's the mistake that that is correct, by the way. I'm going to check it for you in a second. The mistake a lot of people think is they basically say because all the ones before this, it was always 2 away, right? All the ones we did before. So they said, well, if this one in the middle is 11, that one up there has to be 13. Or that one up there has to be 8, or that one has to be 9. Well, do we know what it has to be? Not really. You have to find what x value is going to actually make this work out, because you have 2 x's in there. Okay? And if I put 3 in, this gives you on top here, 2 times 3 is 6, minus 3 is 3, right? Let's see if this works. So if that's 3, this is 11, put 3 in. What do you get on the bottom? So it goes up by 8, goes up by, makes sense. Did you know it was going to go up by 8 when you started the problem? No, you can't just, oh, it's going to go up by this. You don't know that. You can't just make that up. Okay? You actually have to do the algebra. Okay? And again, you could add it. 19 and 3 is 22. Oh, divided by 2 is 11. It works out. Okay? So this is just any old trapezoid. This will work. Here's the isosceles trapezoid. Where have we heard about isosceles things before? Yeah, triangles, right? What did we know about isosceles triangles? 2 sides were congruent, and what do we call those 2 sides? Legs. It's funny how we call these legs too. So which sides have to be the same? Quite obviously, the legs, because here's your parallel. Those are the what called? What are those again, the parallel ones? They said the legs must be congruent. And that's in fact what basically the definition says. A trapezoid where the legs are congruent. It's as if we planned ahead or something. We kept calling things isosceles if the legs were congruent. Isosceles trapezoids have 2 very, very big properties. And once we talk about them, I'll let you attempt the rest of the problems on here, and then we'll come back together and talk about them. Who knows, maybe we'll even have guest presenters again. You can try and spell isosceles right. It's really not that hard, but I see it massacred often. So let's try and get close. All right, one of the properties. Both pair of base angles are congruent. That's, again, if it's isosceles. You may notice as you were writing, I drew a red we don't know it's a trapezoid. No, now we do. On the left, I drew a red trapezoid, and on the right, I just used the trapezoid we already had up there. I numbered 1, 2, 3, 4 in both of them. This black one is, over here, an isosceles trapezoid based on markings. And the base angles here, 1 and 2, are a pair of base angles. Do you believe they should be the same? Yes. 3 and 4 are a pair of base angles. They should be the same. Is that saying 1 and 4 should be the same? Is that what this statement is saying? No, it's saying that pair, 3 and 4 better be the same, 1 and 2 better be the same. Am I guaranteed for that to happen over in this red one? No, because it's not what? It's not isosceles. There's no guarantee. Right? But over there, the isosceles one, that has to happen. And this one here, the diagonals are congruent. You may want to highlight that one. That is by far the most commonly forgotten about the isosceles trapezoid. Not just any old trapezoid. It does have to be isosceles. And again, in the pictures in blue, I will draw the diagonals. Well, draw it straight if you're going to do it. I think it's very simple to see that in the isosceles, at least stands a good chance if you draw it properly that they would be the same, right? And in this red one over here, that isn't even close. Okay? But in that one over there is. Does it say anything about the diagonals bisecting each other, forming perpendicular angles, or anything like that? No, it does not. But it does say they'll have to be congruent, which will make it similar to which two parallelograms that the diagonals are congruent in. Oh, making you think, I know. There's two parallelograms that the diagonals are guaranteed to be congruent. Which ones are they? Yeah, square. Go with that easy answer, right? Square kind of has all the properties, right? Where does the square get that property from? The rectangle. Okay. Any questions about the isosceles trapezoid? All right, so I'm going to pause this then, and I'm going to let you go and try and do 5 through 8, is it? Down at the bottom there, because I've talked enough. I'll come back in a bit. All right, we have some guest presenters, and as always, as a guest presenter, you have your choice as to which one you want to do. If you want 7 and 8, you just have to hit the arrow, and you can do that then. Apparently number 5 we're going to do. 10 and 20, looks good. Presenters adding them together and dividing by 2 using the median formula. So 30 divided by 2, 15. So apparently EF is 15. Do you agree? Yes. Because from 10 to 15 would be going up by 5. From 15 to 20 would be going up by 5. So it makes sense. Very good. Next presenter, go ahead. Yes, you can erase all you want. That's fine. He's got a 6. Very good catch. 10 goes up there, yes. So a 6 and a 10. So you can use the formula on this one. This one's a little trickier. But you don't have to use the formula. All right. I see where that came from. Very good. Kind of using the formula there. Kind of working backwards. This person said, well, if 10's the median, normally when we do the formula, we divide by 2. And so this person said, well, might as well multiply by 2 and get that thing out of there. And they knew they needed 20. They knew 6 was part of it, and so they found out 14 was the other one. Definitely one way you could do that. Another way would be, well, if that's in the middle, how much do we have to go up by? 4. So just do it again. 14. Okay. But this person wanted to use the formula more, which works just fine. Any brave individuals for 7 or 8? Yes, go ahead. Whichever one you would like. 7 has a lot of algebra. 8 is a bunch of angles. Trying. Yeah, I really have to stop letting people up there because they have way better handwriting. Yeah, there are certain individuals that maybe wouldn't work out that way, but. So adding the 2 together, 3 13. Oh, yep, and dividing by 2. All right, so combine like terms there. Deciding to multiply by 2, probably a good choice here because dividing those by 2 isn't the best idea here. You get 3.5, so minus 1, but it still works. So getting the variable by itself. X is 4. Okay, do you agree? Yeah. And when you put it back in, and it doesn't make sense, it basically makes the top AB, if you put 4 back in, you get what, 6, right? And if you put it down here, 3 times 4 is 12, you get 20. And this is supposed to be 13. Mathematically, it doesn't work out. You can check it. Okay, anybody want to do 8? Otherwise, I can just do it quick. All right. It's very important to realize that this problem we're going to take a look at right now can only be done if it's isosceles. Some of the answers you could get if it was just a trapezoid, but some of them it has to be isosceles for you to figure that out. And this one happens to be isosceles. And so if angle D is 52, basically that's all we know. We have a bunch of other angles that we would like to determine. So angle A up there we want to get, angle B, angle BFE, and angle C are ones that we would like to find. I had somebody second hour tell me how to get A, and they went in a very roundabout fashion. Okay? I think that's just because they wanted to give me all the other answers instead of just the one. The quickest way is to realize parallel lines cut by a transversal. So 52 and where that red dot is up by A are consecutive interior, meaning they must be supplementary. And it's a good thing I turned off the mic or you would have heard the entire telephone conversation. But 52, consecutive interior, which means they must be supplementary, which again means add to 180. And so 52 and what would actually add to 180? 128, right? So that's a pretty easy way of getting that one. You could have gone all the way around this thing, but you didn't have to. Again, I think that's just because that person wanted to give me all the answers. At this point, if that's 128 for A, B has to be. And why is that? Because it's isosceles. If this was not isosceles, you would not be able to give me that answer. Because base angles have to be congruent. So now we got 128 right there. So once again, here's your transversal and parallel lines. And so we've got that dot there kind of right here that also are consecutive interior. So that has to be 52. And then C down here also is 52. And what would they be called if I was basing the 52 solely off of those two angles? What type of angles are those? Corresponding, which have to be congruent. Very good. So I told you some of that stuff wasn't going to go away, and as you can see, it really hasn't. Okay, it keeps finding its way back in, and so do triangles, unfortunately. So are there any questions on anything that you have seen today about a trapezoid? All right.